All right, here's our fourth video. So we've identified A, B, and C. We used A, B, and C to find the x values, whether we had to rearrange or not. And now my question of the day is just how many answers there will be. Now, we haven't really talked about this yet, but a parabola doesn't always cross the x-axis, and sometimes it only crosses it once. So we have a couple different situations here. We have a parabola with our xy axis, where it might be something that we're used to, a normal one, I'll call it, and it crosses twice. So there are two solutions, or there are two roots. Okay, you could have it look like that, or it could be a parabola that's upside down, but there are still two roots. Then option number two, I might have a parabola that actually only touches it once, where that vertex is just on it. So there is one solution, or one root. And again, it could be an upside down one. A frown, but it only touches it once. Then our third option is when it doesn't touch it at all. So there are 0 roots, upside down or not. Okay, so what's nice about the quadratic formula is obviously with graphing we can decide if there's one, none, or two, but with the quadratic formula we can actually do this as well. Within the quadratic formula, there's that part underneath the radical that's going to tell me, can I actually find the square root of that number? This part of the formula is actually called the discriminant. While I'm kind of going to brush over this a little bit, I really want you to focus on finding the actual roots. This is something that'll actually help you identify which of these three choices it is. If there's a positive value underneath that square root, then there are, so basically if b squared minus 4ac is positive, that means I can take the square root, that means I can do plus or minus. There are two roots. If it's b squared minus 4ac is 0, that's what's going to happen when there's one root. And when b squared minus 4ac is negative, there are going to be no roots because I can't take the square root of a negative, so that's when it's undefined. So when I have something situation like that, that's what's the parabola is looking like. Okay, so two of the practice problems. Let me just look at one practice problem. I just want to know not what the roots are, but how many there are. So instead of the entire formula, I'm only looking at the discriminant. I'm only looking at b squared minus 4ac. We still have to identify what a, b, and c are though. A, as long as it's in standard form and equal to 0, is 3, b is 2, and c is 48. So what's going to happen here when I do 2 squared minus 4 times 3 times positive 48? So 2 squared we know is 4. So you could type this all in at once, but 4 times 3 times 48 is 576. And if you notice, this time it's just minus that. So what is 4 minus 576? 4 minus 576 is negative 572. So if that number that's underneath the radical of the formula is negative, we decided there are no roots. Okay. And one more, 4x squared plus 2x plus 6 equals 0. So I just want to know how many roots there are, not what they are. I still need to identify A, B, and C. So we're going to figure out just this part of the formula, just the discriminant. That's what that's called, okay? So I have 2 squared minus 4 times 6. What's going to happen here? 16 times 6, so 4 minus 96 is negative 92. So again, my discriminant's negative, so there are no roots. Okay, so let's do one. It's very close to the one I have up above. So this one, I have a c that's a little bit different. Now it's -6. So the thing that's going to change here is this value when I take 4 times, drawing a blank here, 4 times a times c. So I have 4 minus 4 times 4 times 6 is 96, but if you notice, it's negative times a negative. So I'll be adding it. So I'll have a positive value. So if this is positive, then there are 2 roots. And again, the third way is if this ends up being something that you can get to be 0, then there are no roots. All right, that was a quick overview of discriminant. Good luck.